Okay, here Rachel, problem number 2. Okay, find the focus, vertex, and directrix for the parabola x minus 2 squared equals minus 4 into y plus 3. Now, most people will be tempted to solve this problem. Most people will be tempted to, oh, I know how to expand this. So x minus 2 squared, I can expand that. X squared minus 4x plus 4 equals this. I try to assemble terms and see what happens, okay? You can do that and get the answer to this problem. But it's really going to waste you all kinds of time. There's a clever trick. Very clever indeed. And it comes up from time to time. So this will not be the only time you will see this kind of a situation where you can use this kind of trick. What we're going to do is we're going to define a temporary coordinate system. Remember now, the coordinate system here is x, y. So we leave that one as little x and little y, okay? That's the coordinate system up here in which the teacher sets your problem for you. Little x, little y. That's the coordinate system. We're going to invent our own coordinate system. We're going to call it capital X, written like that, and capital Y. That's our new coordinate system. But we have to make sure it's related to what we were given. We can't just invent something, right? So we're going to make sure that we relate it to what we were given. And we're going to make that relationship to be like so. We're going to make the capital X be related to the little x by making the capital X equal to x minus 2, little x minus 2, and the capital Y will be related to the little y by making the capital Y equals to y plus 3. Why? Because this is an x minus 2 in here, so I'm making this my capital X. This is y plus 3 in here, I'm making this my capital Y. See what happens. Why have I done this trick? Why? What use is it? Okay, you should be recognizing that quickly. Well, what do I now have? I now have an equation of the parabola that they gave me in terms of the new x and y, the invented uppercase x and y. I now have a different equation that looks like x uppercase squared equals minus 4 times uppercase y. We know how to deal with this. This is what we've been working with all morning long. Okay? So we know how to deal with that. We can relate it to the standard equation of a parabola, which is what? X squared equals 4p x. I mean y. Okay? That's the standard equation. So it looks like it. And that's why we did the trick. This one didn't quite look like the standard equation. It didn't quite look like it. But this does. And that's what we want. So that's why we did that trick. But it's, you know, it's important to be able to identify situations where that makes sense. You see, they set it up for you exactly so that you'll be able to use such a trick. Okay? Yes, like I said, Rachel, we were working in the newly invented coordinates, the one that we invented, okay, called the capital X and the capital Y coordinates, okay? When we do that, it makes life easy for us to deal with this because we recognize this. So in our new coordinate system, in big X, big Y coordinate system, okay, we can see that this is a parabola that is going to be facing down. Okay, we know that now, and P is equal to, so parabola facing down and P, and we're going to use big P also, equals -1. Okay? So really, let's now proceed and solve for what they want us to solve in the big coordinate system, and then we will translate back to the normal coordinate system, okay? Using this relationship that we started. We defined it, so we can do whatever we want. In math, you define something, you use it, you get your answer, and then you use that answer, you go back using your definition to reverse what you did, okay? So, it's perfectly legitimate, okay? So, P equals minus 1 in the new system, which means we know that, and we said, remember, all this now is in the new coordinate system. We know that it will, because it's a regular, it's one of these, the one I was calling special case, okay? It only has the x squared, it doesn't have the x term, and it doesn't have another constant. It's a special case. So in that case, it's going to be facing down, okay? And this is the cap x coordinate and cap y, okay? So the focus will be what? Right there. And what do we know about it? It's going to be 0 and minus 1. Because we know it's negative, it's below the axis. So we don't have to remember all that, all those funny numbers I wrote for you, I mean all those things on that 4-case diagram that I had earlier. It doesn't have to be memorized. Once you see how your parabola looks, all you know is that it involves P. Okay, so it's 0 minus 1. So that's our focus in the new coordinate system. I keep emphasizing that. We're doing all this work in the new coordinate system. We're going to go back to the old one using those relationships. Okay, so, and then they ask us to find the vertex. The vertex is 0, 0 in the new coordinate system, and then the directrix is right here. In the new coordinate system, the directrix is right here. Alright, it has to be equidistant. This distance is the same as that distance, and it's parallel to the axis. So this is the directrix, and again, the new coordinate system, y, big Y, equals, you know it's going to be 1, okay, because it's above the x-axis. It's equal to P. You know it's related to P, but it doesn't matter really for you to remember the formula. Normally it's y equals minus P is the equation of that line. If you go back and look, it's y equals minus P. And because minus P in this case is, I mean, P is minus 1, so it becomes y equals 1. But like I said, you don't even have to memorize it. You will know what it is, because you know it's got a P there. Whether it's minus or positive, just use your common sense after you, provided you draw your diagram right, okay? So those are the 3 things they asked us. They asked us for the directrix, they asked us for the focus, and they asked us for the vertex. So what do you have to do now? All you now have to do is use this relationship, which we used initially to go from the regular little x, little y at coordinates to go. We use this relationship to go from the little x, little y to the big X, big Y. So now, if the directrix is big X, big Y equals minus 1, that means that, and big Y is y, little y plus 3, that means y plus 3 equals minus 1, little y now. That's what, right? That's the answer we got. So we use that back again. So big Y equals minus 1. I'm sorry, it's plus 1. Big Y equals plus 1. So it means y plus 3 equals 1, which means little y equals 1 minus 3 equals minus 2. So this is your equation. So this is your directrix. Directrix in the teacher's coordinate system. Okay, y equals minus 2. Because you have to give it back to her in her own, in the system she started with initially in the question. So the answer is y equals minus 2. I hope that's right if I haven't made any mistakes. And then the vertex, the focus, 0, minus 1. I want you to do this exercise yourself and convince yourself that you know what I'm talking about. So 0, minus 1, basically, but remember this is for with big X equals 0 and big Y equals minus 1. So all you have to do now is say to yourself, is big X equals 0, what is little x? So you put big X, you set this equal to 0, so 0 equals x minus 2, and you can solve that, right? 0 equals x minus 2, so little x equals 2. And then the minus 1, you come for the big Y. Big Y minus 1 equals little y plus 2. So little y equals minus 1 minus 3. Right? I believe that's minus 4. You do the same for the vertex 0, 0. So the vertex 0, 0 in the big coordinate system, that would mean that x will be what? X minus 2 equals 0, so little x equals 2, and then big Y equals 0 means y plus 3 equals 0, so little y equals minus 3. Right? So in fact, that parabola will look, we can now get an idea of what that parabola looks like. I don't know, let me erase somewhere here. So we see what that parabola looks like. That parabola, now in the regular xy now, okay? In the regular little y, little x. We'll come back. We know its vertex is at 2, minus 3. So its vertex is at 2 on x equals 1, 2, y equals minus 3, somewhere here. Okay, that's its vertex, and its focus. Anyway, its directrix is y equals minus 2. So its directrix is here. Okay, its vertex is here. So you don't need to even do much more before you know that if the vertex is here, it will look like that, and the directrix is there, it will look like that. That's what that parabola looks like. Okay, and then the focus will be somewhere in here. Okay, back in our regular coordinate set. So you can see this is a case where it doesn't the parabola does not pass through the origin, because in fact the original parabola they gave you was not in this form, was not in this standard form. It had the little x squared and little x terms. I hope you understand this. It's not difficult, but it's an interesting little twist on it.